welcome everyone. The idea is for today is to have two presentations from Juan and Nick to talk about OS. In the Ethereum world, we have seen a lot of problems recently, despite of its adoption or having the leading adoption compared to every other protocol out there in the world. Ethereum is struggling with the fees and the scalability and all the other speed related challenges. And many people have come up with different solutions, whether it's a bridge solution, whether it's a plasma solution, second layer solution, ZK rollup solution. And the most recent and quite promising solution that everyone has kind of focused on, and Vitalik has been quite optimistic about it, and all full and pun intended, is optimistic rollup. And this is what we're going to talk about: what optimistic rollup is, where it's using, what are the components of optimistic rollups are, and how we're going to help one company called Fuel Labs based in Toronto is using to make the payments faster. But before we can get started, let's hear from Kevin, the sponsor of the show, who's trying to get together all the aspects and bringing all the speakers to talk about it and what he's up to. So a couple of minutes for you, Kevin, jump in.
Okay, thank you, Chinmay. Just as you mentioned, optimistic rollup is quite a hot topic with, like optimism testnet online, and also we have a lot of use case going on like Unipig and synthetics. So I think when I look into this topic or industry, I found that it's in a small cycle for now. I mean, the inner people, they know a lot about OR, and also, they did a lot of practice. But for people, outside this circle, it still seems like, they don't know too much about OR and what OR gonna bring to the industry. So I hope we can bring the frontline information of OR to the members. And, this is a small group, so I hope everyone can get involved into the discussion. And also, for a little introduction for Metis protocol, because we believe the next bull run of DeFi gonna be on layer 2. So Metis protocol is leveraging and optimizing optimistic rollup and enable DeFi and also other DAO projects to better govern their community via a much stronger governance framework and also more functions. So I think Yuan gonna have more introduction about this project. So yeah, that's pretty much of my part. Chinmay.
Wow. So thanks, Kevin. Really appreciate it. And just wanted to put it out there. This is, although we talked about bull run, this is not a legal advice or investment advice. Please do not consider it as an investment thesis. Just as information only. Do your own research. With that in mind, Yuan, do you want to take over? Please share your screen.
Okay, and, I'll start sharing my screen. Thank you very much for the introduction. Let me get that screen sharing going.
I think I will need to.
Yeah, I need, can you give me the permission to share the screen, please? All right. Can you see my screen now?
Yeah, clearly.
Awesome. Okay. All right. So let's start. So in the next 10 to 15 minutes, I would like to give quite a kind of a high-level overview of what the optimistic rollup is. So this is the agenda. So I do a quick introduction, and I will lay out what the problem is, why we need the optimistic rollup. I will briefly talk about what layer 2 is, and talk about rollups is. Then we talk about the actual optimistic rollups. And in the meat beefer part of the presentation, I will try to get a technical deeper dive of what OVM is. I think it'll be very interesting to our developers out there. And then last part of the presentation, I will do a quick introduction of one of the use cases, which is Metis protocol that Kevin just mentioned. So hopefully it'll be a very interesting ride for everyone. So for myself, I don't know if you can everything. So quick introduction. So I've been in this field for a long time. As you can see, I started programming at 6. My first programming language is BASIC. I don't know if anyone knows what BASIC is, but it's a very interesting language to basically start teaching you about the logic, about the how you command computer do things. I taught myself C at 10 and C++ 2 years later. Interesting things I've never learned officially, like C and C++ is cool. In the universities I attended, the programming language, the choose is Java. But you know, once we know C and C++, any other languages is just a piece of cake. So sorry about Java developers. I did a lot of nasty things in the very beginning when I know how to program. For example, I created a program to lock my parents out from the computers so that I can have exclusive use of the computer. I can do some, I don't know, not to disclose things. So these are some applications I find, hey, having programming skills can actually change life. Actually, it is my drive eventually, my career-wise, my interest in hobby-wise. My constant drive is to bring computer programs to mainstreams and making sure that everyone benefit from it. And my interest in blockchain application and dApps is indeed to bring those decentralized application to mainstream instead of just leave as a hobby for a small group of people. So just some background on my blockchain involvement. I was part of the Hyperledger team at IBM when they were starting the foundation. So I was specialized in the database storage solution for Hyperledger. So it was quite an interesting ride. I got some nice exposures on the little details of how blockchain works, and I really appreciate those experiences. Okay, so enough about myself. So as a general background, why we are talking about rollups, why we're talking about layups, layer twos. So first, we have to establish this thing. I think Ethereum is probably the best thing ever happened to blockchain in the past decade. The reason is it's just a general purpose platform. From there, because of EVM, because existence of EVM, because we have so many smart contracts and it's a Turing complete logic platform, we start to see ICOs. ICO has a lot of negativities around it during period of time, but we can't deny ICO itself really introduced a lot of liquidity into this particular industry, and it gets a lot of attention. So after the emergence of ICO, this industry moves much faster. So the Ethereum itself is moving the industry forward in a rapid speed. And that's why Ethereum is so awesome. And because of ICO, people need to say, hey, what do you want to do with all those money? Then we have this concept of dApps, the decentralized application. And we have interesting ones. For example, the famous kitty cat one, I forgot the name, is Ethereum cat. So that was the one that is really popular at the very beginning of the state. And then we have many interesting apps afterwards. And recently, I would say in the past couple of years, this DeFi, the decentralized finance, is very hot concept. I won't expand too much because time constraints, but hey, it is actually a very awesome platform. At the same time, it's very limited. I don't want to expand too much, but hey, we all know low TPS. I don't know if it's TPS, it should be TPH, should be transaction per hour. And the gas price is getting higher and higher. The more popular the platform is, more people using it. The cost is just too high to use and to execute the method in the smart contracts. And Kevin told me that he had to spend like $4 to transfer a Ethereum once. It's like, this is crazy. This is not suitable for a mainstream adoption.
That's the cheapest one, I think.
That's the cheapest one I had. Yeah. And the user experience is also suboptimal. We have a lot of great extensions, for example, the MetaMask, which is awesome bridge for regular users to start using blockchain a bit more. But think about, you have to do a transaction, but you have to like wait for 10 minutes, 15 minutes, or 20 minutes to finish it off. That is just not a user experience that mainstream audience actually is accustomed to. So all in all, it's just not suitable for large-scale adoption. The Ethereum Catalyst example, when the popularity is so high, the whole network is paralyzed. So how do we solve it? How do we bring this whole blockchain ecosystem to mainstream? This is where layer 2 comes to the rescue. So again, there are many, many solutions of what different types of layer 2 is. I kind of argue whether state channel is a layer 2 or not, but hey, let's just include those. State channel, plasma, and rollups are the ones that are really popular ones at time. And there are a lot of papers behind this, so I'm not gonna expand it. You can Google what state channel is, plasma is, rollup is. There are a lot of great articles to explain the details of what those. But today we're gonna focus on rollups. So what is a rollup? So as the name suggests, it roll up the states to a root state and then published on the main chain. So all the transaction actually happens on the side chain, what we call layer 2. And the main chain we call layer 1, holds the state of that side chain at any given time. So usually we will have a node called aggregator in the namespace of the optimistic rollups. The aggregator will package all those transactions and compute the states using the Merkle tree rollup, and eventually submit to the main chain. Say, hey, this is the state that we think all the transaction results to, and just keep a record of it. And then we use that state to make sure that the consensus reaches and everyone agrees the sidechain does happen. The sidechain transaction does happen. So this is a very simplistic explanation of what rollup is. Again, there are a lot of great papers to talk about, but that's my way of interpreting it. My way, what I think is the easiest way to understand what rollup is. So there are definitely a lot of interpretations, but welcome to Google and find some papers to read, and those are great papers to read. So rollups is a general concept. There are actually many different implementations of rollups. So what we're going to focus on today is what we call optimistic rollup. And there are another rollup I will briefly touch upon in the later part of the presentation. So we can compare what are the differences, what are the pros and cons. For optimistic rollup, we have aggregators on L2. So these are the ones you can consider those are the nodes for the optimistic rollup chain. And they are the one responsible for ingest the transaction, compute the states, and submit the states to the main chain So L1 contracts will have both states and transactions. So there are actual contracts on L1 that is corresponding to the aggregator of the same chain on L2. And those L1 contracts, what they do? They store the states and they store the transactions. But the key to the one distinct difference in optimistic rollup compared to other types of rollups is that when a transaction is submitted to the main chain, the transaction is not validated. There's no validation happening when the aggregator submit that particular package over to L1. All L1 does at that point of time is to, hey, okay, I received this, I will store it, and restore in a contract on the main chain so everyone can see it, and that's it. That's all it does when a package is submitted by the aggregator. And this OVM thing is a term that they use, is a kind of, it is basically EVM. I'll have another slide to expand on that. But it is a state machine where we can execute these transactions on L2 and also on L1. So the OVM is constantly handling the transaction on L2. So that will be executed all the time because L2, the aggregator, needs OVM to compute the states so that they can transfer over to L1. But L1 does not run OVM all the time. When it's going to run is someone figured out, hey, there's some dishonest aggregators. They are trying to spoof the transactions on L2. They're submitting some invalid states. There are other, what we call watchtowers or rangers that Kevin likes to use. They will watch the states submitted by the aggregator and find problems And once they find, hey, there's something wrong over there, and they can challenge those states, if they can successfully challenge those states, they will actually get the bound from the aggregator. And I forgot to mention, in order to be an aggregator, you need to actually stake a bond. Some ethers, some other tokens, you have to have a stake there, and there's a minimum bound required to be qualified as an aggregator. If you're doing some nasty things, you're trying to have some fraudulent behavior, you will lose that bound, and the challenger will get the bound you have staked. So this is like a 30,000 feet overview of what optimistic rollup is. And let's get a little bit deeper into the technical side, how optimistic rollup is implemented. So Aggregator again, Aggregator is indeed a Node.js server. And very interestingly, it works on a private Ethereum chain. So this chain has no ether, no gas, and there's no concept of timestamp in the contract. The chain itself has timestamp. Of course, every block has a timestamp, block number, all those are there. But the contract does not have any concept of timestamp. And same as all the other Ethereum nodes, they have a MariaDB for transactions. Because remember, the aggregator needs to package the transactions and send over to L1. So they actually need to record all the transactions. And I will explain why L1 needs transactions very soon. So if we look at the actual implementation of the aggregator, it is almost like Ethereum private node. There's no communication among the aggregators. So aggregator will work on its own private chain. This chain does not need a distributed consensus. A very important part people have to remember, to be an aggregator, you actually have to pay gas when you submit this rollup request to L1, because you are executing a method in L1 contract on the main chain. So I don't think it actually works if you just blindly accept all the transactions from random people, because you're going to pay all the gas yourself. So there are actually some active research on how we introduce permissions, how we enable the token economy so that the aggregator will actually get their rewards when they're doing those packages. So that's probably another topic we can expand in the future. So let's touch upon this OVM thing. OVM is, to me, is essentially EVM. So it does all the same opcodes. You just have a wrap on top of it because certain things are not supported on L2. For example, there's no ether. So any ether-related functions such as self-destruct, which will actually deposit ether to the parameters in that brackets, is not supported. If you have self-destruct in the contract, the transpiler will actually complain and show you an error saying, hey, this function cannot be used. You have to change your smart contract. And in my experience, I've tried many smart contracts I've written before. Most of the smart contracts just run as is. I don't have to do anything else. The only thing I need to modify are just some certain functions like self-destruct that requires ether to function. Those are very, very easy to modify. So my experience with OVM is extremely smooth. I didn't have any problem with running smart contract on L2. So moving a dApp from L1 to L2 is actually super, super easy. So the transpiler itself doesn't do much compiler stuff because it's transpiler. So what it does, it actually modifies your contract with certain things that is more suitable for L2. For example, timestamp. Timestamp is not supported in L2. I should have a quiz there. Why timestamp is not supported? People can start thinking about it. So anytime we have a reference of timestamping on a smart contract, the transpiler will actually replace that timestamp variable with the actual L2 timestamp construct. That is called execution manager timestamp, but those are details. But you know, that transpiler will actually modify your contract so that it will still run the same logic, but suitable on L2. The average developers don't have to worry about it. So that's our OVM. So let me expand the last piece of the puzzle. Sorry, you can see English is not my native language, so bear with me. So we still need a set of L1 contracts on the main chain in order to get the OVM work. The reason is, so when we talk about optimistic rollup chain, we don't talk about, hey, I have a group of aggregators and they're all working on the same private chain. It's not the case. As I already mentioned, they all work independently. They don't talk to each other on the same chain. When we say there's a chain of aggregators, we all talk about these aggregators are talking to the same set of L1 contracts. That's what we mean by a chain in the optimistic rollup kind of a namespace. So there are a lot of L1 contracts. To be honest, I highly recommend everyone try to start your own L2 construct. You will see there's tons of contracts you have to deploy, but there are the three main ones I want to highlight. The first is a canonical transaction chain. This contract is the storage for all transactions. And why we need all transactions? Because if someone needs to challenge, say, hey, your block is invalid, they need replay those transactions. So to prove what I challenge is correct. So given a starting state, if I replay all those transactions, I'm getting end state, which is different from the aggregator, then this challenge is going to be successful. And this execution is going to happen on L1. So it's going to be expensive. It's going to be slow. That's why the bond is going to be the reward for the challengers, because they pay the gas and they better get a reward. So this replaying transaction happens in the execution manager. This execution manager is what we call L1 OVM. It does the translation of the transactions, and so that they can execute on the L1 EVM. And it doesn't replay all transactions. It's smart enough, knows, okay, you challenge this portion of the transactions. I'm going to only play those. But where do they get the states from? The state is stored in the state manager. So all these three pieces together, all these three pieces fixed together. So we have a actually secure L2 construct that can live on L1, but have an extremely responsive transaction speed. So I also have a little diagram over there, courtesy of optimism.io. So people absolutely can take a look and see, hey, how these constructs are constructed together. You can see a little fraud verifier over there. So these are when they're going to talk to the state manager, talk to the execution manager, making sure that all the transactions can be replayed selectively so that the challenge can happen. Okay, so I do have a little quiz over there. Why timestamp is not supported? I won't give you the answer today. I'll leave that as a homework. Welcome to reach out to us and discuss. There's definitely a very good reason. But hey, if you can answer that, you basically understand what's going on this slide. Okay. Lastly, I want to talk about this another implementation of Rollup. It's called ZK Rollup, and ZK stands for zero knowledge. So it is very interesting, you know why. A lot of people saying that's probably the future of Rollup. I'm crossing my fingers. I hope that's true. They're definitely very interesting construct that they have proposed. The key difference between the two is the ZK rollup will actually do validations when the rollup happens. Meaning that they actually don't have to store all those transactions. They don't have to replay the transactions. In a way, the L1, I would say the L1 effect of all the actual L1 state will reflect the true real-time state of L2 transactions. That is huge because if I have a transaction L1, L2, sorry, in the optimistic rollup construct, I probably need to wait, 30 minutes or so if I have to transfer a token from one L1 account to another L1 account, because that's the amount of time it takes for people to actually have a chance to challenge if there's any fraudulent block. ZK rollup doesn't need that, and this is huge. The only problem of ZK rollup is it doesn't support the EVM. So it doesn't support the full breadth of a smart contract. You can do what smart contract can do. You actually have to modify extensively of your smart contract to support ZK rollup. So a lot of ZK rollup applications are focusing on the payment side, where they can just focus on the token transaction, they can focus on Ethereum transactions, and then they can have a specialized, I don't know, is it ZK VM? I don't know, kind of VM over there they use, so that I guess the key crown to me is that the application or the use case is much more restrictive compared to optimistic rollup. But hey, that's a very, very cool direction. There are a lot of active research going on. I'm also reading papers about that. I have high hopes. Let's see. Maybe we'll get to the point where ZK rollup can actually do everything that optimistic rollup can do. So lastly, I don't want to talk about the limitation of optimistic rollup. Like I said, no timestamp. Also, a very important missing piece we have right now, and mostly the reason why we don't see a massive adoption of optimistic rollup yet, is this token deposit and withdrawal. There are actually many solutions, many implementations. I believe Nick will actually introduce another use case to solve this problem. And even in the general sense, I believe optimistic rollup team are trying to come up with a solution very soon. They already have a roadmap to get to the testnet. So cross my fingers. And actually, the Ministyle actually also have a solution for this one. So let's see who's going to solve it first. All right, so I do want to use a couple minutes at the last piece of the presentation to briefly talk about one use case that we have created for optimistic rollup. It is called Ministyle. It is a blockchain-fueled collaboration platform, and all the transactions collaborations happens on L2, means there's no gas. It just consider if you want to do, for example, a project of a new website, there are a lot of transactions, a lot of interactions between different parties. If all those transactions and interactions has to happen on L1, it's going to be a very costly project. So L2 enables people to actually have a fast response on those transactions at a very, very cheap cost. So it is actually a perfect place for us to be. And it's highly scalable, and we are really looking to this, the concept of DeFi 2.0, where DeFi is on L2, and we can actually enable all those modular things, and we can actually tag on a new module to the platform to enable new use cases, and it's very exciting. So phase one, we're coming out hopefully in a couple months. We will support a single token deposit and withdraw. So we are not going to go as ambitious as optimistic rollup, where they're going to support multiple random tokens. We're going to only support one particular token. It makes our scope much smaller, so easy to implement. And we're going to use a token bridge contract to achieve that. And like I kind of alluded to, having some permission in the aggregator to protect the investment of those aggregators and also the platform holder is very important. And we also wanted to add a more aggressive fraud prevention, and this current minimum bounds is static. We want to introduce more dynamic minimum bounds so that when the project value is higher, you need a more credible, or meaning more bounded stake aggregator to handle those transactions. So I believe that's probably the end. We also have phase 2 and phase 3. So in the future, we do want to support general token deposit and withdrawal. And in the phase 3, we want to introduce a very important piece of the puzzle, which is confidentiality, especially for a collaboration platform. the confidentiality is so important because we do not want everyone to see the details of the one particular project. There are a lot of confidential things here. So this layer is going to be very important to the platform. The goal of this project is definitely low cost, high scalable, and very important to me, mainstream adoption. So I hope this is a interesting journey of what optimistic Rollup is. Hope you find it useful. Are there any questions? Or Chinmay, do you want to leave the questions to the end? Or?
Yeah, no, I think we should do it like questions like per section, and then like maybe like a discussion at the end. If the question you think is like something we should push later on, I think we can do it. I have a couple of questions if you're okay with me asking it first.
Absolutely, go ahead, Chinmay.
So I've heard a lot about Plasma. I've heard a lot about state channels, and I've heard a lot about rollups. More ZK rollups than optimistic rollups in particular. But there are three types of layer 2 solutions in general. Is there a clear direction that one project should take over one over the other, depending on the project? So what are the pros and cons per scalable solution? Is there a map available?
Yeah, there's a map available. Actually, it will be a very big topic. We can probably have another meetup to talk about this. My rule of thumb is if you want to focus on payments,
Okay.
I think ZK Rollup and the Plasma will be a good solution to have. If you want to do more general computing, like what Ministyle is, so our only option is optimistic rollup because that's the only one that supports a general smart contract execution.
Right. So in general, yeah. So if the problem is well defined and something is not going to go outside the bubble or circle, then you would like to stick to Plasma and ZK rollups because they are quite, I would say, more secure and more certain, like in this particular case. But if you want to go a little bit generic computation and you don't know all the use cases that you will need from that particular optimization, then you will go with optimistic rollup. Is that what you're saying?
Yeah.
Okay, awesome. I have a couple more, but before that, I would ask anyone else if they have any questions. Kevin, Stefan, or Stefan, please correct me if I'm mispronouncing your name. Really sorry about that. And AA. Any questions?
Hi, no questions. I'm kind of just listening in.
Okay, cool.
And you had it right, Steph.
No, it's all cool. So I have one more question. So I was reading up on rollups, and I've not implemented rollups, by the way. All I have done so far is just read about rollups. I have read about the implementation of rollup, but never implemented myself. Mm-hmm. And the way I'm understanding it, there is still a case for a relayer and a challenger. Relayer is someone who commits the transaction on user's behalf, and the user pays the fees to the relayers, and relayers kind of creates like a chunk of transactions into one and then commits to the blockchain. And challengers are and the relayer gives the conversion back to the user, which user can use to verify. Now the challenger can challenge if the transactions that are committed in blockchain are correct or not.
Yep.
So if someone is tell me how different or indifferent it is from someone who's staking or validating, if anyone is not staking, by the way, but someone validating and verifying other validators are doing a good job or not. And they get slashed if they are not doing their job properly. So challenger is basically you're doing the same gaming mechanics in this context. But is it like, do they have to stake as well? So do challengers have to stake as well? If their challenge, what they're challenging, and if their challenge is false and that they claim cannot be verified or confirmed, do challengers lose their own stake as well, or that's not the case in this scenario?
So at least I can say about optimistic rollup, the challenger is in what we call watchtowers. They don't have to stake.
Okay.
So what the challengers usually would do is they actually read a read-only state from the blockchain, and they can execute themselves. They don't have to execute directly on L1 because that's expensive.
Yeah.
Right. So they can have their own node. They locally execute a state and see, hey, something's going on, something's not right. then they can decide to challenge. In order to challenge, they have to call a method in the L1 contract. By calling that method, they are paying a gas fee. So if the challenge is gonna fail, if they just like maliciously just challenge random stuff, they're gonna lose all the gas fee for nothing. So it's not economic feasible for them to do though, and it doesn't actually impact the L2 at all, because even when a package is, even when transaction being challenged, it is still committed on L2 until the challenge is successful. So for them doing that, it just doesn't give wings to anyone. So they just the one that's gonna lose all the gas fee.
Okay, so they're not staking anything, but the gas fees itself is the penalty enough if they are literally if they're doing it randomly.
Yeah.
There are easier ways for them to validate the transactions off chain. They don't do it. So this is a similar concept to fishermen in Polkadot, where they fish. Okay, perfect. All right, makes total sense.
It is a very smart design, to be honest. When I read the paper, I was fascinated about this. Oh, this economy is actually wonderful.
That's I know the concept of fishermen quite well, and this sounds very similar. So it's that concept works.
Yeah.
Okay. I have that timestamp question, but I'll probably have to do that as a homework.
It is a homework for you, Chinmay. Message me once you have the answer.
Yeah, we'll discuss it afterwards. But thank you. Any